Okay, this video is about power. Power, power, and power. The equation for power is really easy, just like the equation for voltage in Ohm's law. P equals IV, and voltage equals IR. So there's Ohm's law. These are our two big old fatty equations that we use with circuits, and they're so hard, aren't they? But you know, sometimes we don't know the current or we don't know the voltage, but we do know the resistance. So sometimes what we do is we take this equation, we rearrange it, and then plug it into that one. And I'm not going to do that. But power is also I squared R, or it's also V squared over R. So which version you use depends on what you know. Do you know the current and the voltage? Then you use P equals IV. Do you know the current and the resistance? Then you're going to use I squared R. Do you know the voltage and the resistance? Then you use V squared over R. See? So it's not so hard. Alright, so here's a question. How much power does a 60-watt light bulb use when plugged into a 120-volt outlet? This is actually a trick question because they tell us in the problem that it's a 60-watt light bulb. Remember, power is measured in watts. We learned that first semester because power was our change in energy, how much energy we used per unit time. So it's joules per second, right? And that was watts. So really the light bulb wattages are assumed that you're plugging them into a 120 volt outlet. So a 60-watt light bulb is going to use more power than a 100-watt light bulb, but is going to use, a 60-watt light bulb is going to use less power than a 100-watt, but an 18-watt LED, or what do they call the little fluorescent light bulb, those are going to use less energy than and have less watts than the 60-watt light bulb. A more appropriate question would be to ask what current passes through the light bulb when it's connected to the source. And so we would take our equation, P equals IV, and our power is the 60 watts because power is measured in watts. So 60 is equal to, we're solving for I, times 120. So we find that our current is 0.5 amps. We could also find the resistance of that light bulb because we could use a different version of that, and we could use V squared over R to solve for the resistance. So if we're solving for the resistance, remember this is when our variable's on the bottom, it might be easier to put our power over 1 because that's when we make mistakes. So we have 60 over 1 is equal to V squared, so 120 squared over R. So we get 60 R is equal to 144.00. So R equals whatever that is divided 240 ohms. So that's a way that we could use one of the other power equations to solve our problems. So pretty much it's just like that. You might also want to consider how much it would cost to run that light bulb. So how much would it cost if you left a 60-watt light bulb on all day, every day for a year? This could be the light bulb in a closet. This could be the light bulb in the garage. This could be the front porch light that you leave on all the time. So we're not using power equals IV because we don't have a current, but we do know the power. And remember, power is our change in energy divided by time. So our energy is equal to our power times time. Okay, so look at the units we were given for our energy. Our energy is in kilowatt hours. Okay, kilowatt hours. So we need to take our power. We know our power is in 60 watts. We need this to be in kilowatts, and we need our time to be in hours to find out how much energy we're using. So 60 watts is 0.060 kilowatts. And how many hours are there in a year? There's quite a few. So 1 year, there's 365 days in a year, and there are 24 hours in a day. So let's see how many hours that is. 365 times 24. 8,760 hours. So 0.06 times 8,760 gives us 525.6 kilowatt hours, because we took our kilowatts, we changed our watts to kilowatts here, changed our watts to kilowatts, and this is the number of hours in a year, so kilowatts times hours makes kilowatt hours. So now we know how much energy we used. Now let's find out how much that costs. We had 525.6 kilowatt hours, but we were being charged 12 cents per kilowatt hour. And so if we take that and multiply by 12 cents, that light bulb is costing us, that one light bulb is costing us $63.07 every year. And that's just one light bulb if you leave it on all the time. Now if you were to reduce that to a much smaller compact fluorescent bulb, you know, the CFLs, the little curly ones, those are only like 18 watts. So you would cut this cost by more than half. You'd cut it almost in fourth. So this would only be like $15 a year. And then you could leave 4 light bulbs on for the amount of cost it would be. So something to think about. But we're going to use P equals IV. We might be using the energy is our power times time, depending on if we're trying to find. We're generally going to use this only when we're trying to find the cost. Kilowatt hours we generally only use when we're trying to find the cost. We're going to use different versions of that, so I squared R depending on what we're given, or V squared over R. Or power is our change in energy. So remember, which one you use depends on what you know. Okay, so what do they give you, and what are you looking for? Alright, that's it. See, power's not that hard.